Hi, welcome to the Python Deep Learning uh, fourth module. This ICP is about image classification in CNN. So for this, the dataset we are using is the CIFAR10 dataset. So the first step is like we are importing the required libraries, that is NumPy, Keras, TensorFlow should be installed. So the next step is like I'm just loading the data, that is I'm using the CIFAR10 dataset. So I'm just loading it into the train and test. So after that I'm just finding out the shape of the X train. The shape is like it's a 32 by 32 matrix with three layers. So the next job is like I'm just normalizing the inputs over here. So I'm just I'm just normalizing both the train and test over here. Then I'm just doing the one hot encoding for the outputs. So after doing this, I'm just creating a model. Mm, Creating a model with this conventional 2D layer is of 32 and 3 by 3 and followed by the dropout layer of 20%. Then again convention to like this conventional 2D layer with 30 to 3 by 3 again, and the max pooling with 2 by 2 matrix of 2 by 2, and then again we are flattening the data. So adding the dense layers, then adding a dropout of 0.5 again. So then we are trying to evaluate the model over here. Then we are trying to calculate, we are trying to see the summary of the model over here, where we could find that the total params are like nearly it's 4,210,090. Then I'm just fitting this to the model. Uh, okay, and I'm just calculating it for two epochs. The epochs value is set over here, epochs are two. Um, so after doing this, for this model, I just calculated the accuracy over here, and the accuracy is nearly about 50.78%. So after doing this, the first question is about the performance change, where we are doing a lot of transformations that are mentioned in the question. So again, have added this 64 3 by 3 and dropout of 0.2 64 3 by 3 and max pooling of matrix size 0.2 by 2. Then conventional layer of 128 3 by 3 and dropout of 0.2. Again conventional layer of 128 3 by 3. Then max pooling size of 2 by 2. Again I'm just flattening. Then again this dropout layer of 20%. Adding the dense layers of 1024 um, then again I'm just putting the epochs value as 2 over here, then calculating um, then compiling the model over here, and then I'm just calculating the summary of the new model that has been established after adding the layers or the transformations that are mentioned in the question over here. Then the total params that are obtained are about 2 lakh. Then I'm just trying to fit it to the model again. And the new history object is created over here. So after these epochs are done with it, and then I'm just calculating the scores over here, where the accuracy is found to be 10%, um, which uh, which depicts a significant decrease in the accuracy from the previous model over here. So the second question is predicting the first four images of the model that is created. So I'm just trying to predict the first four images of the model that is created over here, where this is the actual prediction and this is the predicted value over here. And it's found to be like actual is 8 and predicted 1, 8 predicted 8, and actual 0 predicted 8, and actual 6 predicted 4. This basically indicates that out of 4 predictions that we have done, only the second prediction has gone right and rest all has gone wrong. So from this we can infer that the model is not a very good model, because one out of 4 predictions has gone right, which indicates the poor performance of the model. So I'm just plotting the graph for accuracy and loss for the model. So this is the plot for accuracy, for both the train and the test, and this is the plot for the loss for both the train and test model. So this is the third question, and coming to the bonus question. So the bonus question is about saving the model that we have predicted in the before to a H5 form, .h5 format. So this is the model that is M1. This one I'm just storing over here in H5 format. As you can see here, I'm just storing it like m1.save to my model.h5. So after that, I'm just reading the same data over here, and I'm saving it to a new model variable. So the next job is I'm going to predict the data with the help of the new model that I have saved in the above. So after doing that, so now my new predictions will be based on the new model that I have created. So the new predictions showed below are showed below that actual is 8 and predicted is 8, actual is 8 and predicted is 8, and actual 0 predicted 8, and actual 6 predicted 8. This basically uh, shows that we have just got 2 accurate predictions out of 4 accurate predictions, um, which again indicates the accuracy is about 50% that we have got, like in the first one. Mm, so after doing this, these are the predictions that we have obtained after saving the model as a H5 model. And